So we're going to look at combining like terms with negative coefficients and with distribution as well. All right, so this has most of solving equations in it. Obviously, it's not an equation. We're just looking at an expression. But as you build up to solving equations in one variable, there's a bunch of things that you learn. You learn about first of all combining like terms. So the idea that like terms are the same type of number. So let's be kind of clear on this, what a like term is. So the key idea is that if we start with our counting numbers, right? So if we start with just our counting numbers, a set of counting numbers, we've got 1, 2, 3, 4, 5, and so on. All those numbers all the way up to infinity and so on, right? Okay, all of those counting numbers. Every single one of them is a whole number, right? There's actually a name for these. These are a set of natural numbers, and we use a cool symbol to represent them. But more on that in another video, right? Okay, so these counting numbers, they're numbers, and what they actually are. And counting numbers is a really good way of describing them, because what we're actually doing is we're counting values, unit values, right? So we're counting ones is what we're doing. What this one here means is that there is one. And what this 2 means here is that there's two ones, right? And so on and so forth. You can say that for every single value in the counting number. Have you know that say 3 is like saying, well, I got 3 ones, right? 3 times 1, if you like. Right? So that's something that we need to recognize. These are all the same kind of number. They all belong with each other, right? Now, we call those in algebra and pre-algebra and algebra, we call them constants. Okay, so I'm going to just write that in there, constants. And the reason we call them constants is that their value does not change, right? Their value is always constant. Right. Okay. So the second part of this is that we have in pre-algebra and algebra, we have another type of number that we call a variable. And the reason why we call this why we call it a variable is because it varies, right? And it varies based on what the value of the letter might be, right? Now, the interesting thing about a variable is we use a letter, first of all, to describe what the variable is. And we might have multiple different types of variables, right? Multiple different values of variables, right? One of the more common ones that you might see is just the value x, right? And usually when you see them, they've got this kind of nice, like italic, you know, font on them. X represents some value. We don't know what that value might be. And sometimes X might represent something, you know, I mean, you know, X might say, well, it might represent, you know, a number of apples or one apple, right? Or it might represent, I don't know, a bottle of Canada Dry or something, you know, something else, or even more, even more pertinent to you guys with your greenhouse project, for example, X might be the height of your seedlings, right? Okay, and what we do with this is we then start looking at X in various different points in time, right? So we say, well, on day 1, X was, what was the value of X? On day 2, what was the value of X, right? On day 3, what was the value of X? On day 4, what was the value of X? So X is something, X is a value. It actually has a singular value, right? But each time we look at it, we can look at it through different lens, right? So what we have here is 2 times whatever value X is. So if say X equals, I don't know, 14, then 2X is 2 times X, right? That's equal to 28, right? And 4X would be 56, right? But that's if we know what the value of x is. Sometimes we don't know what the value of x is, and we'll go into that later, how to actually find out what the value of x is. Right now, we're not interested in that. Right now, we're interested in the skills that actually get us to being able to solve what the value of x is. And the first skill that we want to talk about in terms of variables and constants is we need to keep these separate. We can never combine these two things, right? We can combine constants together, right? 2 plus 3 equals 5. That's fine, right? We can do that. That's fine. You know, you got 2 plus 3 equals 5. We're good with that. So whenever we see a 2 and a plus 3 somewhere, we can combine those together and we can say, well, that's equal to 5. That's fine. But if we see say a 3 plus 5x, there's nothing we can do with that. We can't combine these together at all. They have nothing in common. We don't know what x is. Remember that this is like saying, well, this is like saying 3 1s plus 5 x's, right? What it actually is showing us is this entire thing is actually 1 plus 1 plus 1 plus x plus x plus x plus x plus x, right? You can't combine them together. That's what this 3 plus 5x actually means, okay? So that's something that we got to remember. We can never combine them together. There are some things we can do with them. We can kind of, this coefficient is what we call the number beside the x. Sometimes we can pull that out and plug it back in again. More on that in a different video. For now, we're just looking at combining them, and we're looking at them with combining the like terms, so combining constant with constants and combining variables with variables, right? And we're looking at it through the lens of also using distribution. Now, let's take a look at distribution. We already know distribution is something that we can do. We can take a number that's outside the parentheses, and let's say we've got a 4 plus 5 inside the parentheses. Well, we can actually take that 3 and we can multiply it times everything inside the parentheses, and we can solve it that way. So 3 times 4 is 12, and 3 times 5 is 15, so 12 plus 15 gives us 27. And to prove that that's true, look at it from the other perspective. Well, 4 plus 5 is 9, so we can look at it as 3 times 9, which we also know is 27. Okay, so that actually works. Distribution works as well. Okay, so this is all the tools you need to start combining like terms with distribution. So let's take a look at a problem. Okay, so right now we're looking at this problem right here. We've got a 19 stuck over there on its own. That one there's a constant. This -6, that's neither a constant nor a variable. That's actually a coefficient, because it's this coefficient outside of the parentheses that can't do anything until you actually distribute it in. So that's the part that we're actually looking at first with the sign that precedes a number, keep it with it, right? So we're going to take this -6 and we're going to multiply that into the parentheses before we actually do anything, right? So what that gives us now is, well, nothing happens with the 19, so we get 19, and then -6 times -k, right? Remember what we said here with the variables, right? That this 5x is 5 x's, right? Well, 6x will be 6 x's, right? In this case, -6 times -k, well, negative times negative is a positive, so we're going to do that part first, right? And then 6 times k is just 6k. Remember, they can't be combined together. You can't get, I don't know, 60k or kt6. I don't know, that's weird. But we can get 6 times k, and that's perfectly fine. Okay, now -6 times -2 again is a plus, right? Negative times negative is a positive. 6 times 2 is 12. Now the next part here is we can see that we have two constants, right? We have two constants right here and here, and we have a variable value in the middle. So we're going to combine the constants together. 19 plus 12 that there gives us 31. So we get plus 31. Okay, and the 6k just stays the way it is, right? So we get 6k plus 31. And this is the sort of thing where we want to be comfortable. We want to start getting comfortable with these kinds of answers, right? Okay, if you have you know, you've got an expression right there as your answer, that's perfectly okay. So start getting comfortable with expressions as your answer, and we should be fine with that.